CMOS logic circuits. CMOS NOR 2 input NOR gate. The design and analysis of CMOS combinational logic circuits can be based on the basic principle developed for the NMOS depletion load logic circuits. In the previous session, figure shows the circuit diagram of a 2-input CMOS NOR gate. Note that the circuit consists of a parallel connected N net and a series connected complementary P net. The input voltages VA and VB are applied to the gates of one NMOS and one PMOS transistor. The complementary nature of the operation can be summarized as follows. Whether either one or both inputs are high, that is when the N net creates a conducting path between output node and the ground, the P net is cut off. On the other hand, if both input voltages are low, that is N net is cut off when the P net creates a conducting path between the output node and the supply voltage VDD. Thus, the dual or complementary circuit structure allows that for any given input combination, the output is connected either to VDD or to ground via a low resistance path. The DC current path between VDD and ground is not established for any of the input combinations. This results in fully complementary operation mode already examined for the simple CMOS inverter circuit. Here you can see the figure A, CMOS NOR 2 gate and its complementary operation. Either the NMOS network N net is on and the PMOS network is off, or the PMOS network is P net is on and the NMOS network is off. The output voltage of the CMOS NOR 2 gate will attain a logic low voltage of VOL equal to 0 and a logic high voltage of VOH equal to VDD for circuit design purposes. The switching threshold voltage VTH of the CMOS gate emerges as an important design criterion. We start our analysis of the design threshold by assuming that both input voltages switch simultaneously, that is VA equal to VB. Furthermore, it is assumed that the device sizes in each block are identical. The WL NA equal to WL NB and the WL PA equal to WL PB, and the substrate bias effect for the PMOS transistors is neglected for simplicity. By definition, the output voltage is equal to the input voltage at the switching threshold. VA equal to VB equal to Vout equal to VTH. It is obvious that the two NMOS transistors are saturated at this point because VGS equal to VDS. The combined drain current of the two NMOS transistors is VD equal to Kn VTH minus K VTN square. Thus, we obtain the first equation of the switching threshold VTH equal to VTN plus root over ID Kn. Examination of the P net in figure shows that the PMOS transistor M3 operates in the linear region while the other PMOS transistor M4 is in saturation for Vin equal to Vout. Thus, ID3 equal to Kp by 2 VDD minus VTH minus VTP VSD3 minus VSD3 square. ID4 equal to Kp by 2 VDD minus VTH ETH minus mod VTP minus VSD3 square. The drain currents of both PMOS transistors are identical, that is ID3 equal to ID4 equal to ID, thus VDD equal to VTH mod VTP equal to root over ID KP. This yields the second equation of the switching threshold voltage VTH. Combining both equations, we obtain VTH NOR 2 VTHN plus 1 by 2 root over Kp by Kn VDD minus VTP by 1 plus 1 by 2 root over Kp by Kn. Now compare this expression with the switching threshold voltage of CMOS inverter, which was derived in chapter 5. VTH INR equal to VTN plus root over Kp by Kn VDD minus mod KTP by 1 plus root over Kp by Kn. If Kn equal to Kp and VTN is equal to mod VTP, the switching threshold of the CMOS inverter is equal to VDD by 2. Using the same parameters, the switching threshold of the CMOS of the NOR 2 gate, using the same parameters, the switching threshold of the NOR 2 gate is VTH NOR 2 equal to VDD plus VTN by 3, which is not equal to VDD by 2. For example, when VDD equal to 5 volts and VTN equal to mod VTP equal to 1 volt, the switching threshold voltages of the NOR 2 gate and the inverter are VTH NOR 2 equal to 2 volts, VTH INR equal to 2.5 volts. The switching threshold voltage of NOR 2 gate can also be obtained by using the equivalent inverter approach when both inputs are identical. The parallel connected NMOS transistors can be represented by a simple NMOS transistors with 2kn. Similarly, the series connected PMOS transistors are represented by single PMOS transistor with Kp2. The resulting equivalent CMOS inverter is shown in figure. Figure A, CMOS NOR 2 gate and its equivalent. Using the inverter switching threshold expression equation for the equivalent inverter circuit, we obtain VTH NOR 2 equal to VTN plus root over Kp by 4kn VDD minus mod VTP by 1 plus root over Kp by 4kn, which is identical to. From equation we can easily derive simple design guidelines for the NOR 2 gate in order to achieve a switching threshold voltage of VDD by 2 for simultaneous switching. We have to set VTN equal to mod VTP and Kp equal to 4kn. Figure shows CMOS NOR 2 gate with parasitic device capacitances with the inverter equivalent and the corresponding lumped output load capacitance. In the worst case, the total lumped load capacitance is assumed to be equal to the sum of all internal parasitic device capacitance seen in figure. Thank you.